solving quadratic equations of the form a times x minus h squared equals k. When solving equations with squares, it's helpful to think of peeling the numbers away from x. So the common analogy is like an onion. You have to peel away the outer or easiest layers to peel away first, and then slowly you can start peeling off the numbers closer and closer to the x. So just to show you what that looks like, we're going to start with x, which is like the center of the onion. And the closest thing we could put to x would be like x plus 3. And then we could add a layer by going x plus 3 squared. And we could add another layer by going 4x plus 3 squared. So these are like the layers with x at the center. And when we go to solve or simplify these equations, or to solve these equations, we need to basically work our way backwards and start by removing the outer layers. So we would, in this case, start by removing the 4, and then we would work our way towards the x. So we're going to look at an example. Our goal in solving any equation is to say what the variable in the equation is equal to. So in this case, we're looking for y. And y has a number of things around it and attached to it. So in order to get to y, we have to peel away those layers. So the thing that's most closely attached to the y is the -7. So that's what we're going to have to do last. And grouping together the y and the -7 is the square. That's basically locking the two of those inside the brackets. And finally, we have this 4 multiplied to the brackets which are squared. And the 4 is the most loosely attached item in all of this, because as we'll see, we can just divide the 4 away. So that's what we're going to do here. We're going to divide each side by 4. And because we just have 4 times this big thing, well, the 4 cancels with the 4 that we divide by. Just like any other equation, right? If you had 4w equals 48, think of w in place of that big squared item. But it's the same thing. If you divide by 4, they cancel. Doesn't matter what w is. So we divide by 4, and then we're left with y minus 7 squared equals, and 48 divided by 4 is 12. So we're going to go to the next item or the next object that's capturing the y or attached to the y. And so the next most loosely one that we said was the square. But we have something squared equals 12, and so we can apply that square root property to say that that something, y minus 7, which was squared, is equal to the positive or negative square root of 12. So we're just using that square root property that we had before. And lastly, the 7 is that last thing that was most closely attached to the y, so we can finally move it. So we're going to add 7 to each side, and we get y equals 7 plus or minus 12. Now I could have written that as plus or minus 12 plus 7, but it's way more common to see that number written in front. It's just a conventional thing. It's just what's standard. And before I put a box around my final answer, I'm going to simplify that square root of 12, 7 plus or minus. The square root of 12 can be simplified because it has 4 times 3, and the square root of 4 is 2, leaving me with the square root of 3 left over. So 7 plus or minus 2 root 3. Just because we get fractions in an equation, it doesn't change our method to solve it. So looking at this problem, we don't have a number in front of the brackets. So the thing that is the outer layer attached to the x is the squared. So to deal with the squared, we're going to use that square root property, which is that if something squared equals 5 over 9, then x minus 1/3 is equal to the positive or negative square root of 5 over 9. Before I move that 1/3 over, I'm going to simplify this right-hand side because I see that it can be simplified pretty quickly here. So I'm going to split apart that square root just like we were doing when we were simplifying radical expressions, because I can see that the square root of 9 is going to be equal to 3. So this is x minus 1/3 equals plus or minus square root of 5 over 3. Now I'll add that 1/3 to each side. So I have x equals 1/3 plus or minus root 5 over 3. And here is where I'm going to write this answer in the way that you'll most commonly see it. This is a correct answer. If you left your answer here, that would be fine. But what would really make your math teacher happy is to write this as, because these two fractions have a common denominator, 1/3 and root 5 over 3, we can write this as 1 plus or minus root 5, all of which is over 3. And that would be my final answer. And again, I want to show you why exactly that's the case. The plus or minus looks odd, but really it's just either, it means either plus or minus. So if I wrote this as 1/3 plus root 5 over 3, or 1/3 minus root 5 over 3, and we looked at these as individuals, we would say, well, these two fractions have a common denominator, so I'm going to add the numerators, 1 plus root 5 over 3. And in the second example, these two fractions have a common denominator, so I can just subtract the numerators and write them over the common denominator. So you can see that whether it's plus or negative, you can do that combination of 1 plus or minus root 5, all of which is over 3. But it was really important that those two pieces had a common denominator to be able to do that.